Good everyone, my name is Graphics. Today we want to study another aspect of mechanical engineering science, we can also say, which is strength of material. Now we will look at this question. The question says that a hollow cast iron cylinder 4 meter long, 300 mm outer diameter and thickness of metal 50 mm is subjected to a central load on the top when standing straight. The stress produced is 75,000 kN per meter square. Assume Young modulus for the cast iron has 1.5 times 10 raised to the power 8 kN per meter square and find the magnitude of the load, the longitudinal strain, and the total decrease in length. Now, first of all, you ask yourself, what is hollow? When something is hollow cast iron cylinder. Now, the two keywords there is hollow and cylinder. We know a cylinder is made up of what? A cycle, right? So a cylinder is made up of a cycle. If I want to do that, I will say, okay, I have something like this. Something like this. This is a cylinder here this way. This is a cylinder, right? This is the cylinder. Well, this cylinder you're seeing here is made up of what? Circular in nature. Now, when I say hollow, it means there is a through in it. So there's what? There's a through in it. It's like a pipe, a water pipe. Without the through in it, water cannot flow through. So you can call a pipe that water flows through as a hollow pipe, right? So the through in it makes it hollow. Then, depend on how thick it is. So the thickness between here and here is what they say is what? Thickness, right? So if I'm to draw this in my orthographic projection, I'll be having something like this. When you look at a pipe straight ahead, right? You see that you have something like this. You see it is standing straight. So let's say it is standing straight. So I have something like this. This coming here this way. And then this coming here this way, and this coming here this way, right? He's standing straight, so he's standing on the ground. So this is the ground here, right? So I'll use this to show that this is my ground, or the floor it is standing. Now they say the thickness, the total, that there's a force acting on it this way, right? But they didn't tell us what that force is, P, and that is the load, right? And this cylinder has a thickness from here to here. There's the thickness of that cylinder, because this thickness here is the thickness you're seeing here, and that thickness from here to here is what? 50 millimeter, right? And we're told that the thickness from this point to this point here is, let's see that, from here to here is given our outer diameter. That means the total distance between the one end of the cylinder to the other end is given as what? Our DO. I'll call it DO, which is our outer diameter. Why this thickness? This one here is called thickness T. Right? Now, from this point here, which is this, and this point here, which is this, is called our inside diameter. From here to here is called our what? Our DI, internal diameter D, right? So there's a force pushing it down, and that force produces stress. When a force is acting on an object, right? Now the object, it tends to push back. So the force here is an axial force, because if I push a wall with 50 kilonewton, since the wall did not break, the word is going to push me back with what is equal kilonewton. So as the force P is acting downward, there's an equal opposite reaction acting upward, right? So it's acting upward, trying to counter this force. Now let's try and write out our parameters and see. The parameter given in this question, let's start and see how it goes. It's a hollow cast iron cylinder 4 meters long. So the length of the hollow cast iron, that means the length, you're standing straight. We're talking about the distance from here to this point here, right? It's 4 meters. That's our what? Our length. So I will write the data given here. Let's move up. My data is very important for you to always write out your parameters. Data given here is that the length of the hollow cast iron is given as what? 4 meters. And also, if you look at this very well, we are told that it is 300 millimeter outer diameter and 50 millimeter thickness. So I'm going to write it this way. The outer diameter DO D0 is O is equal to what? 300 millimeter, right? And the thickness T is given as what? 50 millimeter, right? And the question we are told it is subjected to what? To a central load on top of it. So this load is subjected to it when it's standing straight. So we don't know what our load is. Now the stress produced is 75,000 kilonewton per meter square. So if I write my stress, the symbol for stress is given as what? The sigma, right? And that's given as what? 75,000 kilonewton per what? Meter square, right? And we are told here that we should assume Young modulus of cast iron as 1.5 times 10 to the power 8 kilonewton per meter square. So we should assume Young modulus. Young modulus, the symbol for it is what? Capital letter E as what? 1.5 times 10 to the power what? 8 kilonewton per what? Per meter square. And what are we told to look for? They say we should now determine the magnitude of the load, which is this P here, right? We want to look for what? The P, magnitude of the load, right? P, which is also called the force. We'll call it the weight, and we're looking for that. And also, we should look for the longitudinal strain. Longitudinal strain is given as this symbol here, right? And also, we should look for the total decrease in length. So we use this, which is saying this, right? And that's given as what we're looking for it also. So let's look for the force. Now, if we want to do this, we know very well that for me to get my force, right? For me to get my force, I know that my stress, right? We know that my stress, I'll put it this way. Let's start this way. Calculating for force. Calculating for force P. Now the first question is calculating for magnitude of load. Magnitude of load. Right? So we know very well that we have different formulas. So look for the best suitable one for you. Let's assume you've not solved the question before. So we know that stress, sigma stress, is equal to what? The load P, or you say the force, all over what? Area. Right? Now we know my stress, but we don't know my force, but we don't know my area. So we're looking for A in our parameters, right? So I will call this to be my equation 1. Now I will now write calculating for area. Now calculating for what? For area, right? Now recall. Let's move upward. Recall. Area is equals to what? Pi. Now this will now be d outer diameter minus d internal diameter. The both of them have square, everything over 4. So this is the formula for what? For hollow cylinder. But for rigid, it will be pi d all over what? All over 4. Pi d square over 4. But since it's hollow, we're going to say the outer diameter minus what? The internal diameter. Right? Now we know what the outer diameter is, but we don't know what the inner diameter is. So to save our time, I'm going to come here and calculate for what? Our internal diameter at the top here, which you can do before you start the calculation. Now from here, we know that my internal diameter di, right? Internal diameter is equals to what? The outer diameter minus what? The 2 thickness. Now if you're wondering, how did I get this 2 thickness? Now if you look at this now, it means that the internal diameter di is equals to the outer diameter do minus 2 thickness. This is thickness 1 here and 2 here. This is what we have here. So from here, if I were to put my do is giving, my d naught is giving us what? 300 millimeter, right? Minus the 2 thickness, that is 2 times what? 50, because thickness is 50. So from here, my 300 minus what? 100, and that will give me what? 200 millimeter. Now one thing you need to understand is that what? Everything, you check the stress and the Young modulus, especially the Young modulus, you see what the unit is. The unit is a meter. It means that what? You're going to convert everything you have here to what? To meter. So if I convert 300 millimeter into meter, means I'll divide by 1000, and that will give me what? 0.3 meter. If I have 50 millimeter, if I divide by 1000, it'll give me what? 0.05 meter. Right? And what else again? If I divide, so I will now say that my di here will give me, if I divide 200 millimeter into meter, I'll have 0.2 meter. So this is what we have here. So I will put my di and my do into this equation here. So from here, I will say that the d naught here will now give me, we have this pi are giving us 22/7 multiplied by the d naught we calculated to be what? 0.3, right? Minus the di, which is 0.2, everything here divided by what? 4. This has square and this has square. So if I input this on my calculator here, I'll be having, so this will give me 0.3 square is 0.09, 0.2 square give me 0.04, everything divided by 4, and 22/7 will give me 3.142. So if I should input it here, I'm going to have this as 0.09 minus 0.04, that will give me 0.05 times 3.142, right? So this will give me 3.142 into bracket 0.05 all over 4. So if I multiply it together, right, this is going to give me we have 0.1571 over 4. So dividing it, I will say that my stress here, my area here will give me, divided by 4, and that will give me 0.0393 meter square. How good? 0.039 meter square. So that is my area. So I'm going to input this area into equation 1. So I'll put it this way, substituting area into equation 1, and I'll be having this. So I'll substitute into what? Equation 1. And that is going to give me, we know in equation 1, it's telling me that my stress is equals to what? My force over what? Area, right? So we know the stress is giving us 75,000, and the force we don't know, but the area is what? 0.0393. If you look at our parameters, our stress is giving us what? 75,000, right? So we move forward. Now if I cross multiply, it will be 75,000, right, multiplied by 0.0393 equals to what? P. So the P here will now give me times 75,000, and that'll give me 2945.62, right, kilo Newton. Are we good? So that is our force here. That is the force we have here, the magnitude of the force that we calculated for. So from here, the next we are calculating for is the longitudinal strain. I'm going to put it this way, that calculating for longitudinal strain, and the symbol is this, right? So we know from our formula that because we're going to calculate for longitudinal strain from our question here, right? Longitudinal strain produced. So we know that my Young modulus, recall Young modulus E is equals to what? Stress over what? Over strain, right? Now we know what Young modulus is. In our parameters here, Young modulus is giving us 1.5 times 10 to the power 8. So we have, this will be 1.5 times 10 to the power 8 equals to the stress is what? 75,000 all over, we don't know what the strain is. So if I make the strain, so that the formula, my strain here will be equals to what? 75,000 all over 1.5 times 10 to the power what? 8, right? So the strain here will now give us, now this is what you do here. How will I press it? I'll go to my calculator, right? I'm going to press 75,000 divided by 1.5. I'll press equal sign, right? Divided by 10 raised to the power of what? 8. It will give me 5 times 10 to the power minus 4. So I'm going to write it. The strain is giving us what? 5 times 10 to the power what? Minus 4. We're working with what? With meters. Are we good? So in strain doesn't have any unit. So I'm going to remove this guy here. Right? So from here, essentially I'm writing strain to be equals to what? 0.0005, because 1, 2, 3, 4. When the zeros come before the value, the figure, the 5, you put minus. But when you come after the 5, you don't put any minus there. This is my strain here. Then the other aspect we're calculating for in the question is that we are told to look for what? The total decrease in what? In length, right? Because when you apply a push force here, at the time to compress this, the ground is also reacting to the force, causing a force of what? Compression, right? So there will be a decrease in the pipe. So the decrease, like I said, so I will write again, calculating for decrease in length. So that will give it as delta L, or you put it delta L, any of the two. So if I should do that, we know very well that my decrease in length, delta L, is giving us what? I can say my string is giving us decrease in length over what? Original length, right? So this will now give us the decrease. The string we calculated for is 0.0005 equals to the decrease in length over original length, which is what? 4. We are working in meters, so I can multiply my 0.0005 times 4 is equals to what? Is equals to delta L, decrease in length. So if I multiply it by 4, and that will give me delta L will give me 2 times 10 power what? Minus 3, right? Meters. Or I'll put it as, which is also equals to what? 0.002 meters, right? So this is my, in millimeter, it will be equals to 2 millimeter. So any of the two. So if you found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.